is a stupid question, which means that those questions are stupid which are not asked. So do not think that you're asking a stupid question. So if you feel that you do not follow anything, I mean, the best time to ask that question is that time itself. Always ask it, and I'll try to cover all the questions as soon as possible. And then, yeah. So maybe, I mean, the reason why, I mean, I do video call, if you can switch on your video, if you don't mind, so that at least I can make out from your expressions whether you understood the concept or not. Otherwise, it'll be really difficult for me to follow. I hope you don't mind.
Okay.
Mona.
Yeah, 1 second, sorry.
And when the moment I said Naresh, when Naresh went offline, his video was on. Hello, Naresh, are you there?
Yes, yeah.
Okay, that's fine. So the reason why I asked you to, okay, let me open my video as well. So the reason why I ask you to open your video is because this is a remote way of teaching. So unless until I see your expression, it will be difficult for me to judge out. And sometimes we are hesitant to ask if we do not follow something. And because all of you are from, I mean, all of you have a motivation to learn Java. So we will start with, I'll assume that you don't know anything about computers. So let's start with very, very basic, very, very fundamental. So I'll be sharing my screen. Mohana, what happened?
I'm trying to, again, it's just stopped responding. So
that's fine. Okay, leave it then.
Yeah.
I'll assume that you're understanding and I'm a very good teacher.
Yeah, I'll ask you a question as soon as I get one, sir.
Okay, that's fine. So you have a chat window as well. So in case you have any questions, you can ask your question in the chat window. I'll be sharing my screen. And I hope all of you are recording in case you wish to. So can all of you see my screen? Let me know once you see my screen.
I can only see Kundan.
Yes, yeah, I can.
You're presenting.
Okay. Mohana, can you see my screen?
Yeah, I can only see Kundan Sharma if that's what you're presenting.
No, my Google is open.
No, I don't see it then. I don't see it.
Okay. Just give me a minute. Let me see what happened. Why did not? Okay, let me share it again.
I think because my Zoom meeting, it now says again not responding. That's why I'm not able to start the video.
Okay, so can you just stop it and join it again?
Yeah. 1 second.
Sorry guys, just let's wait for a few more minutes and we'll start immediately. Hello, Mohana, did you manage to join? So, Nitya, how long you have been searching?
I've been searching for 6 months.
You have been searching for 6 months?
Yeah, it's been like, I have applied for more than 2,500 jobs or so.
Excellent. You need to talk to me after the class, probably.
Yeah, sure.
There is definitely something fundamentally wrong in the way you are searching.
Maybe the reason, there are a lot of reasons they have said, but the thing is, it has not past the first stage itself. That was the biggest hole where it is stuck.
Okay, maybe you can share a copy of your CV with me. And Naresh, how long you have been searching?
1 week only. I just finished my contract.
One. Oh, excellent. So I think I did a mistake to ask her to open her video. Just wait for a few moments. So both of you had your dinner?
No, I'm yet to.
Not yet.
Oh, sorry.
Have you had your?
Yeah, I take my dinner early. Okay, fine. In the meanwhile, I'll share the soft copy of the book that I'll be following, so that maybe you will have some idea. Just give me a minute. Not this one. Just give me a minute. Oh, Nitya, you already, I think, shared your CV
Yeah.
with me.
Yeah.
Okay, that's what I was looking at. Okay, that's fine. Okay, just give me a minute. To record, you can record it. Okay.
Okay.
Fine. So I'll be sharing my screen, and now we will start formally the class. Okay. So first of all, we will start with some basics. So okay, let me connect my tablet as well. Okay. So if I ask you, what is this? Does anyone know what is this?
Binary, zeros and ones.
Yeah, this is binary zeros and ones. But what does it mean? I mean,
Machine language.
exactly. So first of all, if at all I ask you what is this number, this is binary number. We all know that number. Let's say if I write 109 or 115, we all know that these are numbers which are represented in decimal system. So this 11001100 is a binary number. So it does not make any sense. What does this actually means? It's just a number. So, but if I ask you that, what does this means? Add A, comma B. So this means that this is very intuitive, very self-explanatory. It gives you an idea that you are trying to add two numbers to it. So add A, comma B is something like which is simple English type statement which humans can understand. But if the same instruction if I give to computer will not understand add A, comma B. Computer always understands the binary language. So when I say binary, computer always understands the machine language. So whenever we type on keyboard, let's say if I'm typing the lazy fox jumping over the fence, so I'm just typing English statement, but internally what command goes to the operating system is just ones and zeros. So whenever you type, let's say if you're typing the alphabet A, the number that goes to the operating system is 97, the binary equivalent of 97. So the point that I'm trying to make here is, a computer always understands the machine language, and humans always understand the plain English type statements. So the primary distinguish, I would say the primary feature, how we distinguish is this is called machine language. This is called machine language. So in case you do not follow anything, please let me know. So I hope all of you understand what is machine language, and this is called assembly language, or you can also call it as a high level language. So assembly language. So we'll just go in the history of programming language. So in the era of when the computer was developed, I mean, computer used to be quite big in size, right? It was used to be, I would say, as big as a huge room size. So in the era of 1950s, initially we had the programming languages which we call as functional programming language. Functional programming language. So what exactly functional programming language means? Functional programming language means where we have, wherever we issue, let's say if I have to issue an instruction to a computer, I say that, let's say, prepare tea. So I'm just issuing a command to a computer. Let's say coffee vending machine. Whenever we press the button, what do we get? We get a coffee out of that coffee vending machine. So basically, whenever we are pressing a button, we are issuing some instruction to the chip which is inside that coffee vending machine. So what does that instruction means? Instruction means that, let's say, the first instruction says take hot water. Let's say take hot water is the first. Then second one says add milk to it, and third one says add sugar to it, and fourth one says, let's say, add coffee to it. So basically what we are doing, we are issuing 4 instructions in just one go. We are giving all this command, take hot water, add milk to it, add sugar to it, add coffee to it. So we combine all of them. We combine all these instructions in one method. Mona, can you hear me? Hello?
I can hear you.
Okay, so we combine all these instructions into, let's say, one method. We call it as a method or a procedure. So let's say that method name or procedure name is prepare coffee. So what is prepare coffee? Let's say prepare coffee. Whenever I type prepare coffee, that means whenever I am saying prepare coffee, the way I issue instruction is prepare coffee followed by a parenthesis. So what I'm saying, whenever I say prepare coffee, it means it will go and read the definition. What is the definition of prepare coffee? It has basically 4 steps. It says takes hot water, add milk to it, add sugar to it, add coffee to it. So this is called procedure. So whenever I have to prepare coffee, if I issue this command 100 times it is going to read this sequence instructions one by one, and it will prepare coffee for me. So this kind of programming is called procedural programming language, where everything is sounding to you like a verb. So this is called procedural programming language. Everything is a verb. For example, if I say that calculate the average marks of the students in a class. So calculate average marks. So calculate average marks is, it is giving you a notion of a verb. Some action is happening. So you will have various instructions. The step number 1 will be take the marks of student 1, take the marks of student 2, take the marks of student 3. Like this, take all the marks. Then step number 2 will be add all the marks. Step number 3 will be take sum of the marks divided by number of the students. So basically you will have 3 steps, and you're combining all those 3 steps into one procedure which says that calculate average marks of the students. So this is, in this again, this is sounding like a verb. So verb or a procedure, or where some action, you get a notion of some action is happening. So this is called procedural programming language. So we have one example. I would say typical procedural programming language is C language. So C language is an example of procedural programming language. So then C language was very popular. All the motherboards, keyboard devices, device drivers, or operating system, or even the Java compiler, that is also written in C programming language. But then C programming language had developed some drawbacks. It had some drawbacks. Over a period of time, people realized that C programming language has some drawbacks. So what are those drawbacks? So the number 1 drawback was that, let's say if you have some more, if you want to enhance this prepare coffee functionality, you would like to add some more flavors. For example, you would like to prepare, let's say, mocha coffee or cappuccino or latte coffee. So what you will do, you will modify the steps of this prepare coffee. So let us say initially the number of lines in this method was 50 lines. So after you modify this, what will happen? It will become, let's say, 200 lines. So that means the code length has grown bigger in size. So it will be really difficult to maintain. And let's say if something goes wrong, let's say if there is a defect in cappuccino coffee, you would like to fix it. So initially it was just 50 lines, but now it has become, over a period of time, it has become 200 lines. So if something goes wrong, so you have to fix that code in the 200 lines of code. Or maybe, let's say, over a period of time, you keep adding some more flavors to this cappuccino coffee, latte coffee, or some other flavors of coffee. So the code number of code size might increase to 1,000 lines. So then it is really difficult to maintain such kind of code where you have 1,000 lines of code. Let's say if you have just one problem in, let's say, the hot water stuff, so you have to scan those 1,000 lines. Or let's say there's a problem in mocha coffee, the logic of mocha coffee has gone faulty, so you have to scan those 1,000 lines and try to find out where that error is. And it might be the case that you will fix that mocha coffee error, and you might introduce some error in other coffee functionality, just like the most of developers like us too. We try to fix something and we break more other things, right? That's a very common thing. So you have to test the whole 1,000 lines of code. So the maintainability was really a very, very big challenge in procedural programming language. So moreover, it was not maintainable. It was very, very difficult. So then people thought of, okay, let's go for some other programming language. Let's think of some better concept. So then came the concept of object-oriented programming language. So I'll tell you what exactly object-oriented programming language is. But first of all, we have to understand that the computer always understands the machine language, which is zeros and ones. So zeros and ones are nothing but they are the binary numbers. So if I'll just take one small example, what exactly binary number means. So let's say if I write 125, so we all know what 125 means. This number is in decimal systems. So this 5 means 5 into 10 to the power 0. This 2 means 2 into 10 to the power 1. And this 1 means 1 into 10 to the power 2. So 10 to the power 2 is 100. 2 into 10 to the power 1 is 20. And 5 into 10 to the power 0 is 5. Because 10 to the power 0 is 1. So 5 into 1 is 1. So 100 plus 20 plus 5 means 125. We all know this mathematics in decimal system. Now let's look into what this binary system means. Let's say if I write 1101. So what does this means? Mona, just stop me if you do not understand something. Yeah. So this one means we are talking of this in the binary system. So what does this binary system means? This is a base 2 and this was base 10. So we have been studying since childhood the base 10. What is base 10? So what is binary system means? Only 2 digits, zeros and ones. What is base 10? Base 10 means we can use 10 possible digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's why it is called base 10. So we have also called octal system where we can use 8 possible combinations, 0, 1, 2, 3, 4, 5, 6, 7. We also have hexadecimal system where we can use 16 possible digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we do not have anything called 10. We have A, B, C, D, E, F. So that is called hexadecimal system. If you do not follow anything, do not worry. I'm just trying to lay the foundation and I'll be repeating those concepts again and again. So don't worry if you do not follow, if you do not retain something, I'll be repeating those concepts and I'll keep repeating so that you understand it fully. So this binary system means, let's say if I say that if I have to understand what does this mean. So this means 1 into 2 to the power 0 and this means 0 into 2 to the power 1 and this means 1 into 2 to the power 2 and this means 1 into 2 to the power 3. So 1 into 2 to the power 3 will be 8 and 0 into 2, this will be 1 and this will become 4 and this will become 0 and this will become 1. So this will become 8 plus 4 plus 1 which is 13. So this number, this means 13. If I'm typing 1101 in binary, this means 13. Similarly, if I type in keyboard, when I type A, what number gets passed to the operating system? It is the number that passes is equivalent to 97, but 97 is not passed in decimal system. It actually sends the binary equivalent of 97 to the operating system. You can calculate, you can convert that decimal system to binary system. You do not have to do it, but I'm just telling you that whatever commands you type, ultimately that gets converted into machine language, that gets converted into zeros and ones. Does it make sense?
Yeah.
Okay, fine. So we all understand this. So I explained to you that the procedural programming languages had several drawbacks. So people came out, thought of, okay, let's try to use something which is more relevant and which is more easy to maintain. So then they came up with the concept of object-oriented programming language. So what exactly object-oriented programming language means? So object means anything that we see in real life, any entity that gives you a notion of noun. So let's say if I talk of I'm having laptop in front of me. So laptop is a noun, right? So noun, that means it is an object, an object that I see in real life, right? So every object will have certain characteristics, certain features. So what all features you can think of laptop? Number one, laptop will have a display. Laptop will have a keyboard. Laptop will have a, let's say, adapter system, right? So these are attributes of a laptop. Or say if you're going to office, so you see lift. So lift is also something that you see actually as a physical entity. So lift will also have certain attributes, certain features. So what all attributes you can think of lift? For example, a lift will have certain dimension. We all see that, okay, this lift can accommodate 550 kg of people. I mean, 8 number of persons. So that is, lift will have certain dimension. Lift will have certain height, width, and maybe the vendor of the lift. It might be a notice lift, or it might be some of the Johnson's lift, or some of the lift. It may be a manual lift. It may be an automatic lift. So these are attributes of lift. So every object that you see in your real life, it will have certain characteristics or certain features.
Okay.
Let's take another example. I'll say mobile. So mobile is also an object, right? So mobile will have certain attributes. What all attributes you can think of?
Screen.
For example, let's say I have an iPhone. So iPhone will have certain attributes, like it'll have a what do you call, smartphone kind of thing. It won't have any keyboard. So in olden days, we used to have a Nokia 1100 mobile in India, back home in India. So that used to have a very hard keyboard. It does not have any keyboard. Everything is a soft keyboard, very smart display. And so mobile will have a display, mobile will have a keyboard, and mobile will have an operating system. Let's say if it's an iPhone, then you have a Apple. Then if you might have a Nokia, then it might have Android operating system. You might have a Windows phone. That operating system might be different. So these are, I would say, attributes of mobile. With me so far?
Yes.
Yeah.
So
how
every,
sorry. How would
go ahead,
it
Moana.
to having a mic and the basic features, having a mic, a camera, and how is that different from having an operating system and the key electrical or mechanical mechanism of the phone is different from the camera and things, or all of them attributes?
Anything that is characteristic of any object, anything that you can think of, that is I would say attribute. Whatever a mobile can have, let's say my iPhone have a very high good resolution camera, so that is also
That's also
an attribute.
okay. Yeah.
Right? There might be a phone which does not have which is not a smartphone, that might not have any camera, or you might have, let's say, a Nokia 1100, which is quite cheap, that will have a very basic camera with very poor resolution. So that is also an attribute. So anything that comes to your mind as a characteristic, that is characteristic of an object. Do you understand this?
Yeah, makes sense.
It's a very, very important and fundamental concept. So whenever we say object will have basically two things. Object will have certain characteristics or certain features. So what do you do with those features? Let's say, what's the point in having, let's say mobile is having a keyboard. So whenever we say object, basically you will have some characteristics and some methods to read or modify those attributes. Let's say mobile phone has a display, or let's say a power mechanism or operating system. So you would like to know what is that operating system, or maybe you would like to modify those operating system. So you will have certain methods to act on those attributes. Let's take another example so that it makes more sense to you. For example, if you have a student is what? Student is also an object. So what all characteristics you can think of a student? Student will have a roll number. Student will have a class. He will have a university. He will have marks, or he will have some, so that will be the characteristics of a student. So what will you do with those characteristics? You will either read those characteristics or you will modify those characteristics. In database terms, we say that we perform create, read, update, delete. So either you will read those characteristics or you will modify those characteristics, right? So every object will have certain characteristics and some methods to read those attributes or modify those attributes. For example, if I have a laptop, so laptop will have a display. Display is one attribute, keyboard is one attribute. So how you read those attributes, you will have a method to say get display system or get keyboard system or set keyboard system or set display. Is it clear?
Yeah. Yeah.
Let's take another example so that makes more sense to you. For example, employee. Employee is an object, right? So what all attributes you can think of employee? Employee will have employee ID. Employee will have a name. He might have a department. He might have a salary. So these are all attributes. So now what do we do with those attributes? I mean, if you cannot read those attributes, then that object is useless. Let's say if you have an object that sits in isolation, let's say human being is a social man. Human being is a social animal. If it does not interact with the outside world, he is a useless human being. So every object in this world has to interact with other object, right? So if an employee has an ID, name, address, salary, so somebody needs to read those attributes and somebody needs to perform some modifications on those attributes. So you might have some methods like get employee ID, set employee ID, get salary, set salary. Let's say if it is your HR department, so HR department might, let's say you have another object called HR. So HR might have to read the attributes of employee. So he might have to modify those attributes. He might have to read those attributes. So you'll have a method like get salary, set salary, get emp ID, set emp ID, get address, set address, get date of birth, set date of birth. So in summary, object will always have two things you have to remember. What are those two things? One is attributes and one is methods to read or modify those attributes. Is it clear? Clear to all of you?
Yes. Yeah.
Okay, so we all know that what exactly object is. So why it became so popular? Because as I said, that object means anything that gives you a notion of a noun, anything that you see in real life, right? If let's say if you're going to let's say play tennis, so tennis racket will also have certain attributes. Tennis racket will have certain dimension, width, brand, what kind of fiber it is made up of. That is characteristic of a tennis racket. So now who will use those tennis racket? A player will actually use that tennis racket, right? Some player has to use that tennis racket. So that player is also another noun that you can call it as an object. So what all attribute player can have? Player can have a gender, let's say a male or a female, or player can have a height or a weight, or the kind of player, the sports that he plays. So that will be the attributes of a player. So now a player object will actually interact with the tennis racket. So basically two objects are interacting with each other. So whenever we say that objects, so what is the advantage of, object-oriented programming language? Let us say I have made the same software that I was talking about. Let's say, again, let's design the same coffee vending machine. So now previously we designed it with the procedural programming language. Now we are saying that we'll use the object-oriented programming language, and let's see how different, how it makes our life very easy. So I will say that, okay, so I'll take one object will be, I will call as, let's say, this is coffee. So coffee will have certain attributes. So what attributes you can think of coffee? First of all, it will have a flavor. Flavor. I mean, that's all I know. This there will be one flavor method. So okay, let me undo this. So okay, I'll come back to this a little bit later. I just don't want to explain the class diagram. So basically let us say if I have designed my coffee system, so I have a separate object for, okay, let's say this is a coffee, and let us say this is my mocha coffee, or let's say this is my user, and this is my, let's say, water supply. Okay, let's not take this mocha coffee. Let's say flavor. Okay, let's take this example: coffee, water supply, and user. So earlier, if something we said that, let's say we were trying to make some coffee, we were trying to add multiple flavors, so the lines of code became 2000 lines. So coffee was having mocha coffee, latte coffee, and let's say one coffee was having some issue, let's say water supply was having some problem. So we were actually writing one common method, prepare coffee, and we had written 4 steps over there: add water, add milk, add sugar, add flavor, and then we were trying to modify the same logic in the same method. But now let's say if there's a problem with the water supply. So in one case, you are saying that prepare coffee method, it had 2000 lines. So let's say this line was responsible for water supply problem. So you fix the problem here, it might impact the other functionalities, or something may go wrong. So your coffee might stop working. The coffee vending machine might stop giving you the coffee. But in this case, we have identified different objects. So coffee is one object, water supply is another object, user who is operating on that vending machine is another object. So let's say if something goes wrong in the water supply, so you know that the water supply, you have a separate object. So you can actually go and fix the logic here. You can find out what is wrong in that. So you do not have to touch the code of coffee class. You do not have to touch the code of a user. You do not have to touch the, let's say there is something called ingredients. I make a object called ingredients. So ingredients could have, let's say, various attributes. So it could have a mocha coffee, latte coffee, flavor, milk powder, sugar, whatever you have another object. So all I'm trying to say here is, if something goes wrong, you do not have to modify the same method, because every object is interacting with each other. So you can actually go and pinpoint where exactly that error has happened. So you do not have to worry about something. If something goes wrong in water supply, you're not going to modify the logic in coffee object. If something goes wrong in the water supply, you will not modify the logic in user object. Is it clear? Naresh?
Yes, yes.
Okay, it's clear. So let's take another example. Let's say you have a television system, right? So if you have a television system, so you have a object called TV and you have an object called remote. So if you try to make a TV system using procedural programming language, so you will have one method, let's say get display, set display, get power on, whatever it is. You will have multiple methods, or maybe you'll have one single method. Once you started with the basic TV mechanism, so TV mechanism will have certain attributes like display, power supply, channels, etc. So if something goes wrong, if it had been developed using procedural programming language, so it will be difficult to pinpoint the figure. You will modify the common logic and the entire logic may go faulty. But let's say if you design the same TV using object-oriented programming language, so what all different objects you can think of? One object could be the TV itself. The other object could be the power supply. The other object could be the remote. So let's say if something goes wrong in the remote, you are not going to modify the logic in the TV. You know that something has gone wrong in the remote. So you can actually isolate the problem because you know where exactly the code is faulty. So you will not modify the logic of TV. Or let us say if laptop, let's take the same example, laptop. So laptop laptop, if I call it as a big object, so laptop will have a display object, laptop will have a keyboard object, laptop will have a hard disk object, laptop will have a mouse object. So let us say if something goes wrong in the keyboard, so you know that there is a keyboard object, so you will go and modify the logic in keyboard. You're not going to modify the logic of display, or you're not going to modify the logic of hard disk. So the object-oriented programming language had the advantage that because you had different objects, they could interact with each other. So if something goes wrong, you know that where exactly to go and fix the logic. So that means code maintainability will be very simplified, much simplified, and moreover, because you can identify how many objects are there.
Okay.
Is it clear?
Yes.
Mohana, is it clear to you? Hello? Hello?
Hear you.
Okay, so is it clear to you?
Yes, it is. Yeah.
Okay, so we all understand what is object-oriented programming language. So now, next question is, so object-oriented programming language became very popular. So we have several object-oriented programming languages. So I'll list few of them. For example, I'm sure you would have all have heard C++, Java, .NET, C Sharp, Python, Ruby, Scala, Ruby on Rails. There are so many. But then important is why we are talking of Java only, why not other programming languages? So we will actually see why Java is very popular. And so let's try to understand all the features of Java. So the very first feature is Java is platform independent. We will understand what exactly platform independent means. Then Java is highly secure. So we will also understand why Java is highly secure. That means no virus can attack. I mean, there is absolutely all human, whatever viruses you see, hackers, Java is, you cannot have virus in Java programming language. Then there is, Java has a very good support for garbage collection. So garbage does not mean that whatever garbage council collects from our house. So we have a concept of garbage collection in programming languages as well. Like we developers create a lot of garbage. So we will understand what is garbage collection. So Java has a very good support for garbage collection. Then the next is Java has support for multi-threading. So what is multi-threading? Multi-threading means you can do multiple tasks in the same time. Let's say we are having a class right now. So it might be the case that let's say Nitya might have to cook meals, maybe dinner. So she might have put something on her stove. And then she'll ask her husband, can you please have a look? Or maybe she has to give instructions to her son or daughter that, okay, have you done your homework? So she's doing multitasking. She's also doing the class here. So that is called multitasking. Or let's say if we are studying something, let's say if we are typing something, so we might be listening to music, or I'm also listening to, let's say, cricket score. So I'm trying to do multitasking. So similarly in Java, you can do multitasking. So there is a concept of thread. We will understand what exactly multi-threading means. Multi-threading means you can spawn multiple threads. Thread is nothing but which executes some task. So let's say if you talk of a simple MS Word application. So whenever you type in MS Word anything, you'll see that there is a spell checker which is running in the background. It keeps checking your spelling mistakes. So you are typing, that is one thread. Spell checker is running in the background, that is another thread. Your computer is also, let's say, playing some music, that is another thread. So multiple threads are running simultaneously. So multitasking, you can just understand in layman's term, multi-threading means you are able to do multitasking. So that's what is called multi-threading. So I would say there are so many advantages in Java, but let's start. These are, I would say, the most few important ones. So Java is platform independent. So what is platform? A platform means basically the operating system. So this is one of the feature which makes Java, I would say, really a very popular programming language. When it came initially, that was the only programming language that was platform independent. So what exactly platform independent means? So means if you write a program in Java, you can run the same program on Windows machine. So we have Windows operating system. The same Java program you can run on Linux operating system. The same Java program you can run on Solaris operating system. The same Java program you can run on, let's say, Macintosh. So different operating system, the same Java program will run on different operating systems. That's why we say that Java is platform independent. This is one of the most, I would say, highly frequently asked interview questions, whether you're a business analyst or you're a tester or you're a developer. Doesn't matter how many years of experience you have. So they will ask, why do you think Java is platform independent? So let's try to understand why Java is platform independent. So it's one of the very important question. So when we say Java is platform independent, so let us see what happens in Java. Let's say I have a class, let's say employee.java. We'll see what happens. So we will compile. So the first stage is called compilation. So when we compile this program, so this will actually be converted into, I would say, byte code. So when I compile this, using, there's a command to compile this program, which is called javac. We will see what exactly javac means. So when we compile this class, then it becomes employee.class. So this employee.class, this has a .java extension, and this has .class extension. So this code is called bytecode. So bytecode is something which is understood by a component which is called JVM. We call it as a JVM, which is called Java Virtual Machine. So we will also see what exactly JVM means. But for the time being, just imagine that JVM is some sort of, I would say, a container where your Java program runs. You call it as a virtual machine, Java Virtual Machine. So what exactly? It is the JVM that makes your Java program platform independent. I'll explain how JVM makes it platform independent. So consider this example, like let's say our Prime Minister. I mean, I hope you all are Indians. So our Prime Minister, Narendra Modi, he knows only Hindi. So let's say if he goes to China, so he has to address the Chinese. So he has to speak in, I mean, a language which Chinese understand. So he will be speaking in Hindi, but he will need a translator that converts that Hindi to Chinese language, right? So basically he needs a specific translator which does that translation from Hindi to Chinese. Let's say now our Prime Minister goes to, let's say, Korea. Again, he will be speaking in Hindi, but then Korean people, they understand only Korean language. So he needs a specific translator which translates that Hindi to Korean language. So now he needs a specific translation machine which does the translation from Hindi to Korean, right? So now let's say he comes to our, let's say UK. He doesn't know English. So he needs a specific translator which does the translation from Hindi to English. So in all these three cases, we see that what is changing? It is just the translator that is changing. But does our Prime Minister need to worry about that which country he is visiting? He need not worry, right? He can go to Korea, he can go to China, he can go to Malaysia. I mean, he keeps flying. I mean, he keeps visiting so many countries. So he does not need to worry whether he knows the local language or not. So what is changing in all these cases is just the translator, the translation machine. So if you see that the translation machine is actually changing as per the country. If he goes to Korea, he needs a specific translating machine that does the translation from Hindi to Korea. If he goes to China, so he needs that the translation machine has to do the translation from Hindi to Chinese. If he's coming to UK, he needs a translation machine which does the translation from Hindi to English. So in all these three cases, what is changing? It is the translating machine that is changing depending on the country he is visiting.
Yeah.
I'm just trying to give you an analogy. So now if you consider that country as the platform and JVM as the translating machine, and the language is your Java programming language. So it is a JVM that will vary depending on the platform. So let's say if you have a Windows operating system, so you will have a JVM that will be specific to Windows operating system. If it is Linux, that means I'm talking of another country. If it is a Linux, then you'll have a JVM that is specific to Linux operating system. If you have Windows, then you will have a JVM that is specific to Windows operating system. But does Java programming language need to care about which platform it is running on? No, because it is a JVM that is doing the magic behind the scenes. So if somebody asks you why Java is platform independent, so you have to say that whenever we compile the program gets converted into bytecode. So bytecode is nothing but, you can say, it is the language of zeros and ones. At the beginning, we saw that what is zeros and ones? It is a binary system, right? So this zeros and ones, it is interpreted by the Java virtual machine. So if I ask you, is Java virtual machine platform independent or platform dependent? So what will be the answer? It is platform dependent. JVM is platform dependent because the translating machine is changing as per the country. So JVM is always platform dependent. But what is Java? Is Java platform independent or platform dependent?
Independent.
Independent.
Okay, Java is platform independent, but JVM is platform dependent. Hello?
You're on mute.
Hello? Hello?
Hello?
Hello? Hello, Kundan? Are you there?
I think he's having some issues.
Oh,
We-
you can hear me. Oh, great.
Yeah.
Okay.
No.
Is Nitya, are you still there?
Yes, I'm there.
Nitya, are you there?
Yes, I'm there.
Hello, can you hear me?
Oh, yes. We can
Yes,
hear
yeah, yes.
So whenever I was speaking, could you hear me? I mean, did I or did you lose something?
you. No. But
No,
I
no,
think
no.
Nitya is gone off.
Okay, so Nitya, I asked you, is Java platform independent or platform dependent?
Java is independent.
Why can't I hear you? Nitya, I can't hear you. Can you
Oh,
just check the audio options in Zoom? Yeah. Go ahead now.
It is
Hello?
independent. Java is
Okay.
independent. JVM is
Okay. Okay, excellent. So now we understand that Java is, whenever we say Java is platform independent, what does it mean? It means that it can run on any platform. So interviewer may ask you, is JVM platform independent or platform dependent? So you should be able to answer it. The JVM is always platform dependent, but Java is platform independent. Right. So whenever you forget that which is platform dependent or which is platform independent, always remember this analogy that I gave you, the translation one. Okay.
Okay.
Okay. So clear so far, right?
Yeah, I have one question. So only Java is the platform independent programming?
No, there are other programming languages. Python is also platform independent. Now there is a huge competition in the market. So there are many more programming languages. But very soon you will come to know why we are only talking of Java only and why not other programming languages. So there are 3 billion devices which are actually using Java.
Yeah.
So Java is one of the, I mean, when you install Java, you'll actually get to know.
Yeah.
So we will actually see why Java has become, so Java has so many other features that do not come with other programming languages. So there are many features like Java is now getting the best of both functional as well as object-oriented programming language. So we said that initially the procedural programming language or the functional programming languages had some drawbacks, but it also had some few good things. So now Java is embracing all the good features of, so I would say best of both the worlds. So Java has inherited all the good features of object-oriented programming languages, and it has also borrowed some good features of functional programming languages. So the latest version of Java is Java 9, and it has embraced all the good features. So it has mix of both, best of both the worlds. So Java is platform independent. Python is another programming language that is platform independent, but C++ is platform dependent. So like this, there are many other programming languages which are platform independent. So okay, so now next is, so I hope you all understand what is Java is platform independent. You all understand what does it mean. So we will actually see what is JVM in a little bit in detail when we actually try to install Java. So let us understand a few more things before we proceed further. So let me save this screen. So JVM. So okay, we'll come back to it a little bit later. So we say that Java is highly secure. So what do I mean by highly secure? So if you see this byte code, I just gave you a sample example 11001100. So this is a byte code which is generated by a compiler. So whenever the way we compile a Java program is the command is Java C. So we use a command, if I have to compile this class employee.java, the command that I will use is Java C employee.java. So whenever I compile this Java program, what will be the output? When I compile this, the output will be employee.class. So whenever you compile this Java program, you get output as employee.class. We will see in future how that employee.class looks like. So employee.class is a byte code. If you try to open it, you will not be able to read anything. It will not make any sense to you because it is a bytecode to be understood by the machine. It's a machine level language. You cannot understand anything. So how do we execute this command? With the way we execute this command is Java, and the name of the class is Java employee with no suffix. It's just how do we command, how do we compile it? Java C employee.java, and how do we run that program is Java employee. So when you run this, you will see the output. So now the point that I'm trying to make here is the compiler actually compiles that program and it converts that into a machine language. So if you see if you open the employee.java, you will see the attributes. What is employee is an object. So employee will have certain attributes like ID, name, salary, address, and you will have some methods like get ID, get name, get address, set salary. So those methods are simply human readable English type statements which you can understand. That is a high level language. So whenever we say Java C employee.java, that converts that high level programming language into a machine language, a code that machine can understand. So that's what is called bytecode. Right. So there is a component which understands this machine code. So that the name of that component which understands this machine code is called JVM. It is a Java virtual machine that understands that interprets that bytecode. Is it clear to you?
Yeah.
Okay. So now we have two components in Java. One is called JDK and one is called JRE. So JRE stands for Java Runtime Environment and JDK stands for Java Development Kit. So whenever you try to install Java, you will see that both of these, they come together. We will see what exactly, what comes with JDK, what comes with JRE, but let's try to understand at the very broad level what exactly JRE means. JRE means Java Runtime Environment. So what exactly runtime environment, which is actually used to run your Java program. So what do you run? Do you run Java C employee.java or do you run the compile version? We never run the .java file. We always run the machine language. It is the machine language that needs to be run. We do not run the Java program. We always run the machine language. The bytecode is actually run. So to run the bytecode, do you actually need the JDK? JDK is Java Development Kit. So what exactly Java Development Kit means? Like I'm a Java developer. So if I need to write some Java program, so some library that has been developed by Java guys, Java team, basically Oracle team, or I would say the primary team which developed the Java was Sun. So the Sun people, they developed some API, some libraries. So those using those libraries, I develop my Java program. So those libraries are available in this JDK. I will show you, on my screen quickly what exactly JDK looks like. So let's have a quick look. So this is my computer, and if I go in C, program files, Java, and you can see here I have multiple versions of Java. So can you see JDK 1.8.0161? So if I open this JDK, you'll see that we have so many JRE lib. If I open this lib, so you can see that these are different jar files. So dt.jar file, Java FMX. So there are so many jar files that you see here, tools.jar file. So these jar files are basically, you can consider them as, I would say, all the compressed jar file is, I would say, just like a WinZip file. I'm sure you would have used WinZip in your computer at some point of time. So WinZip, whenever you compress your file. So these jar files are nothing, they are the compressed version of the libraries that some people have developed. So using these libraries, I develop my program application. So as a developer, whenever I say I'm working as a developer, so I'm not actually trying to develop Java. I'm trying to develop a program using the libraries given by Java people. So to be honest, I'm not a Java developer. I use the API provided by some people. So the people, those who have developed Java, they are the actual Java developers. I am simply using those libraries provided by some people. So Java developer means I use these libraries to develop my program. Okay.
I'll be back in 5 minutes. Someone is knocking my door.
Oh, that's fine.
Kundan, I can't see your screen anymore.
You can't see my screen.
No.
Why can't you see my screen?
For some reason.
Okay, let me pause here and resume again. So I'll be sharing my screen again. So can you see my screen now? Mohana. God, what happened? Hello? Can you hear me, guys?
Yeah, I can.
Mohana, can you see my screen? We can see two Mohanas.
She said she will be back in 5 minutes.
No, Nitya said she'll be back in 5 minutes. She's back. I can see her on the screen. Hello, Mohana, are you there? Let me call her.
Hello?
What happened, Mohana?
Yeah, I think the app closed itself again.
Well, let's wait. She's joining. I think her app closed again. So
Okay.
okay, we'll make sure that all of you test your app before joining the class. Otherwise, all of us have to wait. Okay, I think we should start now. I cannot wait. So she can watch the recording later. Okay, so I was saying that using these libraries, you can actually develop your Java program. So whenever I say JDK, that means I'll be using the libraries provided by Sun, and I'll be developing my API. So this comes under JDK. So JDK, hello, finally we can see you. Mohana, can you hear me?
Hello, can you hear me now?
Yeah, we can. Yeah.
Yeah, good.
Okay, so I hope you're recording this video.
Yes, I am. Yeah, I will start again. Yeah.
Okay, allow record. So now you can record it. So
Yeah.
Okay, so what I was saying, so using this whenever we say JDK Java as a Java developer, I actually use these APIs, these jar files, which comes as a part of JDK. So this is the version JDK 1.8. So the latest version in market is JDK 1.9, right? So, but we will be following JDK 1.7. So several things have changed between JDK 1.7 and JDK 1.8. So we'll not talk about those differences, but I would say JDK 1.7, let's say if it is at 5 meters, then JDK 1.8 is at 12 meters. So just imagine that there is a huge difference. So in order to understand JDK 1.8, I will strongly recommend that first you should understand JDK 1.7. Okay. So, but for automation purpose, you do not have to worry. I mean, it is a headache of the developers. They need to upgrade themselves. But if you want to be an automation tester, I mean, you should be good enough with JDK 1.7 as well. So whenever I say JDK 1.7, I'm talking of Java Development Kit, right? So what is Java Development Kit? The set of libraries provided by some people to write the Java program, right? So we will see how do we use what all libraries are there. But at a broader level, just understand that whenever we say JDK, that means we are talking of the libraries provided by the Sun. Now let's talk about what is JRE. So you see that there is a folder called JRE 1.844. So this JRE folder, this comes with almost all the opera computers nowadays. So you do not have to install JRE. So any computer will always have JRE. By default, the latest laptops, they will have JRE. So which means that JRE is used for running your Java program. Java program runs using this JRE. So whenever I say your Java virtual machine, it is actually part of JRE. So JRE is Java runtime environment. So your Java program needs to have JRE. So if I ask you that if you have a Java program, do you need JDK or JRE to run? So the answer is you need JRE. You do not need JDK. So JDK is Java Development Kit, which a developer needs to develop his Java program. But JRE is the library which is used to run the Java program. So let us say if I have written, let's say if I get, I'm developing a software for, let's say, a third party. Let's say now today I'm working for post office. So I develop a certain set of APIs for post office that I have bundled all the entire application in the form of a jar file. I showed you these are all jar files. So jar files, if you see this carsets.jar file, deploy.jar file. So these jar files, I mean, I have compressed all my compiled versions. If I see this deploy.jar file, few minutes back, I showed you that when I compile this Java C employee.java, what is the output? It is employee.class. When I compile in a .java file, the output is .class file. What is .class file? It is a, I would say, bytecode of employee.java. So if I combine several such .class files together, let's say I have employee.java, employee.class, hr.class, or let's say software engineer.class, department.class. So I have so many classes. If I compile all of them and club all of them in form of one file, I'll call that file as a jar file. So effectively, what is the jar file? So jar file is Java archive file. I have whatever application I have developed, I will compile all of them. After compiling, I will club all of them into one single file and I'll call it as a jar file. So that is the jar file is a group of combined version of the .class file. Is it clear? Naresh?
Yes, yeah.
So you understand what is jar file? Jar file is basically a group of binaries. .class file is bytecode, or you can say binary code.
Okay.
So .class file is a binary code or .class file. So basically, if you combine several .class files together, it forms the jar file.
Okay.
Okay. So in order to run your program, what do you need? Do you need JDK or JRE?
JRE.
JRE.
You will need JRE. You do not need JDK.
Right.
So when you install Java on your system, basically you install both JDK and JRE. Let us say if you are a tester, let's assume that you're working as a tester, you have to test some application. So in order to test your application, when you will be installing Java, so do you need to install JDK or JRE?
JRE.
You need to install JRE because you need to test. All you need to do is test your application. Let's say if you're trying to test a mobile app. So in order to run a mobile app, you will need class.
Okay.
And the JVM always understands the bytecode. Understood?
Yeah.
Okay, so we say that Java is highly secure. Why do we say Java is highly secure? So whenever we compile any Java program, so it generates the bytecode. So every compiler in this world, it generates, whenever you compile a Java program, it appends some fixed particular number of characters in the bytecode. So the first 8 characters in the bytecode is a specific, I would say, sort of indicator that will tell that this bytecode has been produced by which compiler. Is it a valid compiler or is it a, I would say, human injected code? So if you are trying to inject a virus, basically you'll try to write some malicious program. So if your bytecode does not have those magic number, when I say magic number, basically it's a predefined set of bytecode which actually identifies that which compiler in this world has generated this bytecode. So if it is a human injected bytecode, automatically, I mean, the JVM will figure out this is not a code. This is not a code generated by a valid compiler. That means it could be a virus. So that's the reason Java is highly secure. It will give you an exception that not a valid code or some security error exception you will get if you try to run a program that is malicious, or which is I would say some human being has deliberately tried to tamper that .class file. So JVM will immediately come to know that somebody has tampered that .class file, because the first 16 bits, I think, yeah, first 4 bytes of any compiled version, it has a flag which indicates that which compiler is it a valid compiler or it's somebody that has deliberately injected some bytecode in that. So if it is a deliberately injected bytecode, the JVM can pick out that it could be a virus, so it will not let you run that program. Is it clear?
Yeah.
Okay. The next is garbage collection. So what exactly is garbage collection?
Sorry, could you repeat that the first 4 digits thing? I didn't understand really.
I mean, that's fine. Don't have to worry. You just have to understand that. Let's say you have a bytecode. Bytecode is nothing but ones and zeros. Bytecode it's a machine language of just ones and zeros. I have not spoken about what is byte. 1 byte means 8 bits.
Okay.
If I tell you what is 1 byte, so not sure if you know this. 1 byte means 8 bits. It means that 1, 2, 3, 4, 5, 6, 7, 8. So like this is 1 byte. This will means 2 byte, and this will means 3 byte. This will means 4 byte. So first 4 bytes are a particular sequence of characters using which we can identify whether this code has been produced by a valid compiler or it is a deliberately injected code. So that is called magic number. Right? If you don't know, then don't worry. Don't take too much of stress. I'm just telling you for the sake of, I mean, you should know this. If you know it, it's good. It's always good to know. So this magic number basically helps you identify whether this is a valid code or not. So whether it is a virus or it is it's generated by a proper compiler. So that's the reason Java is highly secure. Then the next feature is garbage collection. So what is garbage collection? So if you see the previous programming languages like C++ or any other programming languages, so the most competitor, I would say, programming language was C++. So C++ had some drawbacks. C++ is also an object-oriented programming language. So what happens, so far I have not talked about objects. I mean, we have discussed about objects, but how we as a programmer create objects. I have not discussed how do we create objects so far. But whenever we create object, I mean, any programming language, let's say if your laptop is having certain resource constraint, you cannot have infinite amount of RAM. Let's say if you have a very sophisticated lap, you might have a 32 gigs RAM, or your laptop might have 16 gigs RAM or 8 gigs RAM. To run your Java program, you need certain amount of memory. Hello?
Yeah. Okay.
Nitya, are you there? Looks like Nitya has.
Yeah, I'm there.
Hello.
I'm there.
Okay, that's fine. So whenever you try to run a Java program, it actually needs certain amount of memory. So that memory it's a finite amount of memory. You cannot have infinite amount of memory. So whenever we run any Java program, we actually create some objects. So if you have a finite amount of RAM, basically, so every object that you create, it will need a certain amount of memory. So you cannot keep creating as many objects as you want. There is a limit to the number of objects that you can create. So let's say if you keep creating objects, and it's simple to the example. Let's take a simple analogy. Let's say if you have a garbage bin at your house. So let's say if you keep accumulating garbage in that bin, and if you do not empty that bin, what will happen? At some point of time, it will overflow, right? So you need to empty that garbage periodically. You need to keep emptying that garbage. Otherwise, what will happen? It will start overflowing. So you don't want to be in that situation, right? So similarly, consider that your RAM is a limited resource. So if you keep creating objects, and if you do not remove those objects, what will happen? At some point of time, your program will fall short of memory. You'll not be able to run your program. Your program will be, there'll be a performance issues. So whenever you are creating some objects, basically, you as a programmer, you have the responsibility to remove those objects from the garbage. So is it clear or not, the analogy?
Yes. Yeah. Yeah.
So you need to empty those garbage from the garbage bin. So let's say if you have a RAM, let's say if you have 16 gigs RAM, so you cannot keep creating objects, as many objects as you want. If you keep creating objects without removing those objects, and by the way, when do we remove those objects? Whenever we see that, okay, this is definitely a garbage and I'm not going to reuse this object. Then we throw that object into the bin. If you know that, yes, we are going to reuse this object, then do we throw that? Let's say if you have 10 pounds, do you actually throw that 10 pounds into the bin? No. Nitya, I think we lost you.
I was there. I was in mute.
I can't hear you. Can you check your audio options? Or maybe you can type on chat. Did you miss anything? Okay, you can hear, that's fine. So you did not miss anything. So I was saying that garbage collection, that means we put only those things in the garbage which we know for sure that we are not going to reuse it again. Let's say bank statements come to us, we keep throwing in the trash bins, right? We know that it's simply a garbage. We have seen it, then we don't need it. So we simply throw that in the garbage. So similarly, as a programmer, if we keep creating objects, if we know that certain objects and we are not going to reuse those objects, then it is our responsibility to get rid of those unused objects. So some people, they saw that programmers are really lazy. They do not want to, let's say, even if you have created objects, but they will never get rid of those objects. They'll say, okay, let it be. It's not my responsibility. Someone else will come and clean the house. So some people decided to develop a component which will take care of cleaning the garbage. जैसे हमारे घर में जो है बाई होती है, यहाँ पे तो नहीं होती है, but India में we have maids, right? It's very costly to afford a maid here. So we have maids in India, so, right? So we know that, okay, maid is there. So we are very careless. We throw some trashes on the floor. We know that, okay, next time maid will come and she will clean the garbage. So similarly, some people decided that, I mean, this C++, when I say C++ programming language, it was always the developer's responsibility to get rid of those unused objects. So if developer is not careful enough, let's say if he is an inexperienced developer, so he will keep creating objects and he will forget to remove those unused objects. So what will happen at some point of time, your application will crash because it will run short of memory. So to avoid this problem, Java came up with another component. They said that, okay, we will not let this responsibility to be held with the programmer, but instead we will develop a component which will take care of doing this house cleaning job periodically. So they have provided one maid which will do the house cleaning. So that maid's name is garbage collector. So garbage collector always, what it does, it keeps running in the background periodically, and it keeps removing the unused objects, right?
Yeah. Okay.
So So in my application in which I was working in post office, so there was an error, out of memory error we were getting. So what is that out of memory error? I mean, the application was creating many objects. There were many threads. They were creating objects in the loop. And after some point, I mean, it was overflowing. The garbage collector was not actually removing those objects. So because of that, garbage collector was not performing its job. So the programmer had made some mistakes. So all I'm trying to say is, you as a developer, it is your responsibility. If you're not reusing those objects, so maybe you can just make your object eligible for garbage collection. We will see the garbage collection rules, but the responsibility of cleaning those unused objects from the memory is the responsibility of another component, which we call as a garbage collector. So what is garbage collector? Its job is to clean the garbage. It will periodically check if there are some unused objects which are not being used by the programmer. It will simply remove those objects. Is it clear?
Yeah.
I know it's a very boring session. I mean, we will actually see some code, but initially, I mean, I'm just trying to set to the background so that if I start using some vocabulary, it should actually make sense to you. Otherwise, it'll absolutely make no sense to you. I mean, if you open that PDF book, you'll be completely scared. So you'll stop reading Java. So I don't want you to do that. So I'm just trying to set the background. So we all know what is garbage collection now. So Java has a very good support for garbage collection. So that's one other reason why Java became so popular as compared to C++. Understood?
Yeah.
The next is multi-threading. I mean, I've already seen that multi-threading, like Nitya was attending classes, then somebody was at the door. So she said, okay, she paused the video. She went to open the door. Let's say you might go for a cup of coffee. Let's say if you're feeling sleepy. So you can do multiple tasks, right? So that is called multi-threading, right? Normally, we also do we as a human being, we do multi-threading. Like I listen to my wife. She keeps saying, I pretend that I'm listening to her. I'm also checking my son's notebook. So that is a multitasking. I'm also checking my emails. I'm also checking my WhatsApp status, my Facebook status. So that is called multitasking. So similarly, Java also has support for multi-threading. So you can do multiple tasks at the same time. So I would say these are few features of Java. Now why should we learn Java? Let's try to understand. So the first reason is you all need a job. That's why we need to learn Java, right? Okay, so that's not the only reason. So let's see why do we need Java? So the first thing is, I'm talking of, okay, Java. So Java has basically, I think I told all of you, Java has 3 flavors of, basically one is called J2SE, which you call Java 2 Secondary Edition. Then I said J2EE, which is Java 2 Enterprise Edition, and J2ME, which is Java 2 Millennium Edition. So all the mobile apps, whatever you see, mobile apps, games, etc., that you download from Play Store, or what do you call Play Store? What's the other one? Google. I forgot. Anyways, leave it. So all the mobile apps that you see, those are developed in using J2ME, Java 2 Millennium Edition. And what is J2EE? Any web application that you see, all the websites, Expedia.com, Instagram.com, Facebook.com, Twitter.com, MakeMyTrip.com, Google.com, Yahoo.com, Google.com. So all these websites which you can access from anywhere across the globe. So they are enterprise level applications. So these components are developed using enterprise technologies, so which is called Java 2 Enterprise Edition. So what you will see some words maybe in your day-to-day life, if you're working in IT industry, like servlets, or Tomcat, or JSP, or web services, or microservices, or RESTful services, or Spring, or Hibernate. So all these jargons, they form of a JSF, JSP, struts, React. So these are all enterprise level technologies. So these are all part of J2E, which is Java 2 Enterprise Edition. Right? So it's JSP, servlets, Spring, Hibernate, React, JavaScript, web services, RESTful web services, SOAP-based web services, Tomcat, WebLogic, application server, web server. So these are all part of J2EE. Naresh, you mentioned that you were testing mobile applications, right? So you also mentioned about some web server, web applications. So all those web applications are part of J2EE. Then comes J2SE. J2SE is Java 2 Standard Edition. It is core Java. So what exactly is core Java? Core Java, as the name indicates, core. Core means, I would say, the most important part, right? Fundamental. So core Java is basically meant for standalone programming applications. So what exactly is standalone programming application? Let's take a simple example. Let's say you come to my house. So you press the, let's say you have a smart keys to my house. So you touch the door and automatically it will sense something and it will open it, right? Or let's say if you have a car keys. If you have a car keys, when you open the car key, what happens? With the moment you press the car key, automatically it recognizes, okay, this is a valid key and it opens the car door. So where exactly that logic is residing to identify that whether this is a genuine car key or it's a fake car key. So the entire logic resides in that car key itself. The entire logic is embedded in that chip. It is not going to any application server. It is not making a call to Google server to find out, okay, from your key, it will go to some application server, then it will come back to your car. No, the radio waves, etc., they are emitted, and the entire logic to identify your car is embedded within that chip itself. So it is a self-contained unit. It's not talking to any application server. So the entire logic is on that particular component itself. If you try to see that logic of that car key, you'll not be able to access over the web. So it is a standalone program. If you open the doorbell using a smart key, let's say I have a smart key, so I'll touch this key like this. Let's say this is a key at the doorbell. If I touch it like this, automatically a beep will open and the door will open. So the logic to identify whether it's a valid key or not, that is embedded inside that smart key itself. So that is a standalone program. So similarly, J2SE is only for standalone program. In simple words, I would say, let's assume that Microsoft Word is a Java program. So if you install Microsoft Word in your laptop, so only you can access it. If I try to access your MS Word from the internet, I cannot access your MS Word because it is installed on your laptop. I will not be able to access it. But if you have to check your Gmail, you can check your Gmail from home. You can check your Gmail from office. You can check your Gmail from France. Let's say if you're holidaying. So that means gmail.com is available across the web. So that is called J2EE. But J2SE is something which is purely standalone Java program. So now what exactly is in Java J2SE? So basically there are 11 chapters. There are 11 chapters and they will decide your life. So those are very, very fundamental chapters. If you master those 11 chapters, you will not regret. Trust me, you're not going to regret. So those 11 chapters, if you master it, so if I say 11 chapters, I mean, I sent you the link of those 11 chapters. It is contained in that book and it is written by Kathy Sierra. So those 11 chapters, if you understand it, basically, if I think I told you earlier as well. So if you know, this is 70% is core Java. So if you know core Java, you have already covered 70%. Then this 30% bit, it has basically two directions. You can be a Java developer like me. I'm not a good Java developer. You can be a Java developer if you wish to be. Other option could be you can be an automation tester, right? I'm sure you'll be an automation tester. So if you put additional 30% of efforts, you can be a very good automation tester. If you put additional 30% of effort, you can be a Java developer. And important thing is there is absolutely no difference between a Java developer and an automation tester in terms of rate wise. I'll not tell you what is my contract rate, but I'm just telling you that rate wise, there's absolutely no difference between automation tester and a Java developer contract rate. Right. So now next thing is what you should be doing. You should be actually be focusing for, I mean, I strongly emphasize that you should go for Java certification. Why you should go for Java certification? I think I told you earlier as well. There are so many testers in the market, but you have to do Java certification. That will put you ahead of existing contractors in the market. You'll be way ahead. Basically, having a Java certification is something like saying that you are I would say you are a sophisticated automation tester. You are different from others. If I interview, if I ask for a CV, I'll get thousands of CVs. But if I just see only 5 CVs which have automation, Sun certified Java programmer written over it, those CVs will be preferred. Like Fujitsu also hires many contractors. So they just see if you are a Java certified programmer or not. Right. So having a Java certification definitely adds a lot of weight on your CV. I mean, I cannot emphasize enough the importance of Java certification. Anyway, so let's come back to the topic. So we said that Java has basically 3 flavors. So we will be focusing only on core Java first, right? So let's go back to the next topic. So we started with history of programming languages. I told you we had procedural programming languages. Then there were some drawbacks in the procedural programming languages. Then we came with object-oriented programming languages. Then we said why object-oriented programming language became so popular, because we could identify the entities whatever you see in the real world, you can make it as an object. And it was very easy to locate the problem. If something goes wrong in your software system, you know that, okay, this object is responsible. So you can locate the problem, you'll go and change the logic in that particular object. Let's say if you're trying to, as I gave the example, let's say washing machine could have a several mechanism. Like washing machine could have I would say spinner, a place where you put your detergent, and you have a control panel. Let's say if something goes wrong in the control panel, you're going to change the logic in the control panel. You are not going to change anything in the place where you put detergent, or you are not going to change anything in the spinner part, because you know that spinner is one object, control panel is another object, your detergent area is another object. If something goes wrong, you know that which area you should modify the logic. So that's how the object-oriented programming language became very popular. Whatever you see in the real world, you convert them into object, and different objects interact with each other. So far, I have not discussed how to make object. An object will have always 2 things. It will always have characteristics or features and some methods to read those attributes or to modify those attributes. Is it clear?
Yeah.
Okay. We also discussed about why Java is platform independent. We said that it is a JVM that makes Java platform independent. I gave the example of the analogy of translator. Now let's see the most important interview question. Have you heard this word? No, not the English one. Okay, so it is object-oriented programming, not the English word oops. No, not that. So oops, I mean it's the acronym. So object-oriented programming system. So one of the most important, most frequently asked interview question. Again, as I said, whether you're a automation tester or a manual tester or a Java developer with 1 year of experience or with 20 years of experience, the question remains same. What is OOPS? So let's try to understand the various principles of OOPS. I'll try to make it not too boring and theoretical. The first principle is abstraction. The first principle of OOPS is abstraction. So let us understand what exactly abstraction means. I'm sure you all must have used your debit card, right? So you go and you try to insert your debit card into a ATM. So when you insert into that ATM, what happens? Then you enter your key. Then you see some options. What do you want? You want to withdraw some you withdraw some money. You want to deposit some money. You want to change your PIN. You want to pay some gas bill. You get different different options in your ATM, right? So when you actually enter your card, do you actually know what is happening? I mean, when you swipe in, how does that, it says, okay, enter your PIN here. When is someone sitting inside the ATM machine who is looking, okay, someone is trying to insert it, let me issue the instruction? Or there is some intelligence which is inside that magnetic chip. There is some intelligence inside when you scan it. So when you scan it, what happens? Does it go to the bank? Does it go to the satellite? Or does it go to some application server? Which application server? Is that application server sitting in US or it is sitting in London? Or does it go to Australia or does it go to India? Or let's say if it goes to some server, then does it go to some Oracle database to find out which user card, whether it is ATM card, Visa card, debit card? Does it go to Oracle server, or does it go to a SQL server, or does it go to MongoDB? Do you know the database? You don't know. Or let's say when you get that option, enter the pin. So you enter, let's say 1576, for example. So 1576, when you're entering it, so does a call go to the customer care and find out, okay, Mona has entered her pin 1576. Is it actually the pin code? You say, yes, it is a valid pin code. Allow her to withdraw money. Or does a call go to the database? Which database the call goes to? Do you actually care for these details? If you actually have to know these many details, that which is the database the call is going, which server is actually used to, which is storing your details, whether it is what programming language you're using. Are you using C programming language or Java programming language to develop that UI? If you have to know all these features, will you actually be using that ATM card? If I say that, if I put a condition that if you have to use this ATM card, you need to know all the details, which database is actually storing your details, what programming language is using it, whether the call goes to a local branch of London or it goes to Manchester branch, or which application server, which database your details. If I say that you have to know all these details before you actually able to use that ATM card, you will never be using that ATM card. You'll not be interested, right? You'll say it's very complicated. I don't want to know those details, right? So basically what you're saying is you have been given a ATM card which is actually acting as a proxy for the bank. It is just like a wallet. All you need to know is just swipe it, enter your PIN, and you say withdraw 50 pounds, the 50 pound comes out. You don't worry about the internal details. Is it right?
Yeah.
Or let's say if you go to purchase a AC, or let's say if you go to a shop, you say I want to purchase a television. So what do you see in a television? Do you actually say, can you please open this TV? I want to see how many capacitors are there, or what length of capacitors or inductors, or what circuitry. Is the PCB made in China or it is coming from Hong Kong? Or what RAM, how many embedded chips are there? Whether those chips have been prepared in Taiwan or it has been manufactured in India or maybe in US. Do you actually care about those details? No, you don't care about those details, right? So all you're interested in, okay, if you are going to purchase a TV, you'll say, okay, you'll switch on the power, the display comes. Or maybe what you'll try to change the channels. If you change from channel 1 to channel 2, are you able to change the channel or not? If you'll try to increase the volume, decrease the volume, that's it. So all you need to know is how to use that component or how to use that object. You do not worry about the internal details. The internal details are hidden from the user.
Yeah.
So if you have to use a washing machine, all you need to know is where is the power to switch on the washing machine, where to put the detergent, and where to put the clothes, how much clothes you need to put. Do you actually need to see the internal circuitry of the washing machine and understand it, how to use it? If I say that you have to understand the entire circuitry of washing machine, will you actually use that washing machine? No, because that will give you a lot of headache. I don't want to understand the internal circuitry. So this concept of hiding the internal details from the user is called abstraction. Is it clear?
Yeah.
Naresh?
Yes, yeah.
Okay, so we all understand what abstraction is. So the next concept is polymorphism. By the way, all of you understand Hindi?
Yes, yeah. Yeah.
To an extent.
Nitya? No?
Yeah.
Sorry, I can't hear you. Anyways, I assume that I'll stick to English this time. So polymorphism is, poly means more than one. Morph means shape. Polymorphism.
Yes.
Okay, fine. So polymorphism means, I mean, we all studied science till at least class 10, I assume. So we all have studied graphite and diamond, right? Or I would say coal and diamond.
Mm-hmm.
Coal and diamond both are allotropes. Both
Yes.
are allotropes of carbon, right?
Yes.
Yeah, both are allotropes of carbon. So Both are carbon, but one is very precious and one is absolutely useless. So both are carbon only, right? So carbon is existing in two different forms. One is in coal and another one is in diamond form.
Yeah.
So similarly in Java also, the same method can do multiple things. Same method can exist in multiple forms. So that concept is called polymorphism. Okay, before I explain polymorphism, let me try to explain something else. Let's call inheritance. We all know what is inheritance means. Inheritance is also one of the important concept of polymorphism, right? So we all want to inherit our properties from our parents, but we don't inherit. We don't want to inherit the advices or lectures given by our parents. We say, yes, we are interested only in the money. Don't give lectures. So inheritance means we inherit all the properties. So in simple words, I would say, we all inherit some traits from our parents, from our biological parents. Like I look like my father, so I have inherited certain traits from my father, right? So, but there might be certain traits or certain attributes which I might not have inherited from my father. Inheritance is a simple English word. Don't try to relate it with some any programming language. Just inheritance means whatever we inherit from our parents. So if you have a parent object, you have a child object. So all the child object will also inherit some attributes from the parent, right? So as I said, I look like my father, so I have inherited some features of my father. So certain attributes that are inherited by the child object, or I would say the child class. I will tell you what exactly class means, but just assume that there is a concept called class. I'll come to what exactly class means. But let's say the child object has inherited certain attributes from the parent object, right? So that concept is called inheritance. So any attribute which is non-private, by the way, private attributes means, let's say if you have private car parking, let's say if you have a private car parking, only you can park your car in that car parking. No one else can park that car into your car parking. That is called private car parking. No one else can use it. But if it's let's say if it's a public car parking, so anybody can park that car. So similarly, if there are certain private attributes, that means it is specific to that particular object. No one else can inherit those objects. So if you have some attributes, like your parents might have certain features, certain peculiar features which is specific to your father, you might not have inherited. But all the other attributes you might have inherited from your father. For example, like your physique might be like your father, you might be very tall like your father, you might be dwarf like your father. So some attributes that you inherit from your father. So all the non-private attributes, when I say non-private means they are public attributes. Basically, all the public attributes or public features you inherit from your parent object in the child class. Is it clear? So this concept is called inheritance. Now, why do we have inheritance in software? So what is the advantage of software? I said that every object will have two things: characteristics, basically attributes, and some methods to act on those attributes, right? So let's say I have a parent object. I wrote some 50 methods in the parent object. I have written some 50 methods in the parent objects. Now I have a child class. So one option is, if I want to have the same attributes, same methods in the child class, I rewrite those 50 attributes. Or the other option is I inherit those attributes from the parent object. So if I inherit those methods from the parent object, do I need to write those 50 methods again? No, because I have already inherited it. So if inheritance promotes reusability, you can reuse the features which you inherited from your father. Amitabh Bachchan is very famous, right? Abhishek Bachchan is not famous. Do we need to do anything? He has inherited all the fame from his father. He can reuse it. He don't have to work. Yes, I mean, whatever his father has earned, he has inherited from it. So he don't have to earn that wealth again. Whatever is available, he can reuse it. So whatever attributes you inherit from your parent, you can reuse it. You do not have to rewrite it. So what is the advantage of inheritance? The code reusability. Whatever code is written in the parent class, you can reuse that code in the child class. Is it clear to all of you? Okay. At least raise your hand, right, if it is If something is not clear, maybe I mean, just raise your hand. I'll try to explain. If you're not raising your hand, I'll assume that it's clear to you. So inheritance will promote code reusability. I hope this is clear to you. Okay, now let's take another example. As I gave the example, like we all are interested in the fortune that we inherit from our parents, right? आपने बोला ठीक है भाई इतने सारे पैसे ठीक है, I'll pass on my inheritance to you. But let's say if your father says, okay, I have fixed your marriage with so and so person, you're not happy with that. So no, I would like to marry a person of my own choice. So what will you do? You will try to override that decision. So you want to inherit. You're happy with the default methods that you inherited from your parent. Whatever inheritance you inherited from your father, you're happy with that. You don't want to say, okay, give me whatever you're giving to me. But let's say if you have fixed your marriage, you're not happy with that. So you'll say, I want to override that decision. Right? Dil wale dulhaniya le jayenge, Amrish Puri wali picture. I'm sure, right? You all have seen. Amrish Puri बोलता है कि ठीक है सिमरन की शादी करेंगे, ऐसे करेंगे, वैसे करेंगे, लेकिन शादी जब बोलेंगे तो हम वो पटियाला वाले कुलदीप के साथ करेंगे, तो शादी उसके साथ मंजूर नहीं है. So if you're not happy with that marriage, so you will try to override that decision. So you are inheriting whatever default method is present in the parent class. So if you're happy with the default implementation, you would not like to change it. But something which you're not happy with, you would like to override, you would like to change it. So let's take a simple example. I'll say, now I'll try to draw a diagram. Let's say this is a rectangle box and it will have 3 rows. The first row will have the name of the object. Let's stick to the name of the object. I'll tell you what exactly object means. Object or class means the same. I'll tell you the difference. What is the difference between object and class? But let's assume that this is class. So let's say this is your parent class. Parent class has one method is, let's say, marriage. Sorry, I need to undo this. So parent object will have certain attributes and certain methods to act on those attributes. So I'm keeping these attributes as empty, but let's say one method is there, marriage. Another is wealth. So this diagram is called class diagram. So this notation is called UML. I'll tell you what exactly UML means. UML is Unified Modeling Language. So UML means that, let's say if you go to a builder and say that I want to get my house constructed. So that builder will try to draw a map on a piece of paper. He'll say, this is how your bedroom will look like. This is how your kitchen will look like. So he'll draw a rough sort of sketch that will give you an idea. Visually, you can imagine that, okay, my house is going to look like this. So similarly, if I'm a software developer, if I'm working with, let's say, a team in India, so I need to tell, okay, this is how my software is going to look like. So I need to give that counterpart some sort of a map, or basically some sort of structure using which he can understand how that software is going to look like. So that language is called Unified Modeling Language. If it is not clear, just raise your hand. If you do not raise your hand, then I'll understand that you understood it. So Unified Modeling Language is a language used by IT people like me and you who try to convey something to the team. So that is called Unified Modeling Language. So class diagram is one such, I would say this is called a class diagram. So before I go into class, I'll explain what exactly class means. So so far I have been talking about object. So class is basically a specification. A specification means class, or I would say, so you can call it as a template. For example, if I'm saying mobile, so mobile is what? Mobile is a class. But if I say iPhone, so iPhone is a specific instance of mobile. Instance means, if you see, for instance, instance is an English word. For instance, or for example. So iPhone is a instance of the class mobile. So Mobile is something specification. So mobile will have certain specification. What are specifications you can think of? Mobile will have a display, whether it has a smart key phone or touch key phone, or what kind of power system it is, or whether it is a what operating system. These are all attributes of a mobile. But if I say, give me a specific instance of mobile, so you'll say iPhone is a specific example or specific instance of mobile class. So class is, you can call it as a sort of a template. And instance or object is specific example of that class. For example, if I say book, book is a class. I gave you the certification by Kathy Sierra. So Kathy Sierra, certification by Kathy Sierra is a specific example of a book. Book is very generic term. Book is a class. It's a template. Book will have certain attributes. Book will have index. Book will have pages. Book will have, let's say, a cover. Book will have an author. But the specific instance, let's say, Wings of Fire by APJ Abdul Kalam. So that is a specific book. The author is APJ Abdul Kalam. It might have 50 pages. Or we have a Tata McGraw-Hill. Let's say I don't even read so many books. My daughter reads so many books. Let's say we have a Harry Potter series. I don't even know who is the author. So you have so many books. There's a specific example of a book. So book is a class, and object is a specific instance of that class. Is it clear to all of you? If it is not clear, I can explain again. So I assume that all of you understood what exactly class means, what exactly object means. If I say drink, so is drink a class or an object? Mute. Okay. Anyway, so
Class.
drink is a class. But if I say hard drink,
No. Yeah.
so that's an object. If I say cold drink, or let's say if I say Pepsi, so Pepsi is a specific example. If I say Coke, so Coke is a specific example. So Coke is an object. Pepsi is an object, but drink is a very generic word. So drink is a class. So class is something which has a specification. Is it clear to you? Naresh, is it clear to you?
Yes, yeah.
So we all understand what exactly class and object. Okay. So I was explaining that we have a class, a parent class, and in the first row, we will write the name of the class. In the second row, we write the name of the attributes. I'm just keeping it as a blank for the sake of simplicity. And in the third row, we will be writing the method's name. I said that every object or every class will have attributes and
Methods.
the methods to act on those attributes. So this is a UML class diagram. So in the second column, I would say in the second row, we'll have certain attributes. For the sake of simplicity, I'm keeping it blank at the moment. But let's say the third row will have methods. So we say marriage and wealth. So this is a parent class. So now I'm using a solid arrow and I'm using a child class. So this child class will inherit all the non-private. Basically, plus means public. Plus means public. We'll see what exactly, I mean, just English word. Public means open for all. Private means it is specific to that. Public means certain features which are, I mean, let's say, which can be inherited. And private means which cannot be inherited. So these are all public methods, marriage, wealth. So child class will inherit all these attributes, all these methods, marriage and wealth. So you are happy with the wealth, whatever millions of pounds your father has passed on to you, you'll be very happy to accept those wealth. Like you don't want to override that. You'll never say no to it. You'll say, okay, give me the money that you're giving. But let's say if you're not happy with the marriage, so you would like to override, you would like to change that definition. So if you're not happy with the default behavior of the method, you would like to change that. So that concept is called overriding. Is it clear or not?
Yeah, yeah.
Let's take another example. Let's say you have a car. The parent class is car. Every car will have certain attributes. Every car will have a pickup. Every car will have, let's say, steering wheel. Every car will have, let's say, some seats. But so if you, let me take another example here. So let's say I have a basic car. Let's say the parent name is car and say pickup is one method. Let's take one example, only pickup. So let's say I have a child class. So how do we inherit, how do we denote a relationship in Java? In UML, basically we use a solid arrow and using this we have a child class. So let's say this is a sports car. So will you be happy with the basic pickup feature that comes with the basic car in a sports car? A basic pickup, I mean, basic pickup is, let's say you're not happy. So a sports car is always meant to have very high pickup, right? So you'll not be happy with the basic default behavior of the pickup method that you inherit from the parent class. So what you will do, you will inherit that method, but you will change the implementation. You will change the meaning of that pickup. You will redefine basically. Is it okay?
Yeah.
So what is method overriding? The method that you inherit from the parent class, if you're not happy with the default implementation, you will change the behavior. That concept is called method overriding. So all of you know what is method overriding?
Yes.
Very clear?
Yeah.
Okay. So then there is a concept of method overloading. Let's try to understand what is method overloading. Let us say you're working in a loan department of a bank. I'll take another example. Let me save this or save. So let us say you're working in a loan department, okay? Loan. What are the attributes loan can have? The most important is what? Interest rate. If higher interest rate, will you be interested in a loan? No. And what is the type? I would say
Number of years.
other attribute could be type: personal loan, marriage loan, vehicle loan, education loan. So many types of loan are there, right? So loan is the name of the class, and these are the attributes. So what will you do? Well, you'll have some methods to act on those attributes, right? So loan class will have some methods. So what methods you can have? Let's say calculate interest rate. Okay. So calculate interest rate is your method name. So now, let's say if you have a car loan, so you will have one method called calculate interest rate, and the argument type is loan type is car loan, right? So the method name is calculate interest rate, and the argument that you're passing is car loan. Let's say you have another method called calculate interest rate. You keep the method name as same. Basically, you want to reuse the method name. You do not want to give a different method name for different kinds of rate of interest. You want to reuse the same method name. So what are we doing? We are keeping the method name as same, but the argument type is changing. So in the first case, the argument was car loan. In the second case, the argument is home loan. Neend aa rahi hai, Mohana? Okay, I will be finishing quickly. Calculate interest rate. The next one is personal loan. So we are having same method names, but different argument types. So this concept is called method overloading. In a class, if you have same method repeated multiple times, but the argument type is different, then that concept is called method overloading. What is method overriding? Wherever you have a parent class and you have a child class, you inherit all the non-private methods from the parent class in the child class. If you are happy with the default behavior, you don't disturb that. But if you're not happy with the default behavior, you override the implementation. So that concept is called method overriding. So when does method overriding will come into picture? When we have at least two classes. And those two classes should be related to each other. What should be the relationship? Parent-child relationship. You will never have method overriding between the two siblings. always parent and child. So what is method overriding? Method overriding is whenever you inherit some method from the parent class, if you're not happy with the default implementation, you change the implementation in the child class. So this concept is called method overriding. What is method overloading? Method overloading is you reuse the same method in a same class. So for method overloading, how many classes are there? Just one class.
Yeah.
Just one class, but you have the same method name and the argument type is different. So that concept is called method overloading. Is it clear? I mean, if you're tired, if you want to
Yes, yeah.
stop it, let me know. But I hope so far it is clear to you.
Yes.
Yes, yeah.
So we have understood what is abstraction, the first principle. We have understood what is inheritance.
Yes.
We have also understood what is polymorphism. So polymorphism is, it has two flavors, method overriding and method overloading. I have just introduced you these topics. They have, I would say, in detail, we will be studying these topics individually. But all I'm trying to do is, do you know, have you seen that Lego? Lego. The kids, then they try to make some robots out of that Lego.
Building blocks.
Building blocks, basically. So what I'm just trying to show you, these are different logos. And then we will try to assemble those logos, and then we'll try to build some software out of that logos. So far, I have not taught you Java. I'm just telling you the different logos. So once we understand ABC fundamentals, if fundamentals are really clear, then you will never have any problem whether you want to be a developer or an automation tester. So it's very important that you understand those Legos really well. So we have understood what is abstraction, what is polymorphism, what is inheritance. So the fourth rule and the last one, the last rule of the polymorphism is encapsulation. So let's try to understand what is encapsulation. So this is this clear to you, all of you?
Yes.
Naresh?
Yes, yeah.
Okay. So let's try to understand the fourth rule, which is encapsulation. So encapsulation means what is this? This is capsule, right? So the medicine is kept inside this capsule. Why medicine is kept inside this capsule? Because medicine is highly reactive in nature. We want to protect that medicine from the outside environment. We do not want that medicine should react with the external climate. If it reacts, what will happen? The medicine will become poison, right? So we want to hide that. We want to hide the medicine within that capsule. So similarly, in Java or in any object-oriented programming system, we have the concept of encapsulation. We hide our data. Will you be comfortable by sharing your salary with the whole world that, okay, I earn 3,000 pounds or I earn 4,000 pounds? No, salary is a confidential data, right? You do not want that confidential data anyone else should know. Similarly, for a student, he would not like the whole world to know his marks, whether how good or bad he did. So marks is also a confidential data. Or let's say for that matter, mobile number. Mobile number is also confidential data. So there are certain data which you would not like the whole world to know, right? So let's take one simple example to understand what encapsulation means. So let's take one class. I'm saying that my class name is, let us say, employee. Okay. So the first row will tell the name of the class. This is the UML. This is called class diagram, right? UML, I explained what UML is, Unified Modeling Language, the language which is used by developers. So Mohana, I mean, business analyst also understands this UML. Okay. So this is the employee class. So employee class will have certain attributes. For example, salary, and let's say mobile number. So we'll have some methods like get salary, or let's say there might be set salary. If HR is trying to revise your salary, so there will be set salary. Get salary to read the salary, set salary to change the salary. Similarly, get mobile number and set mobile number. So for the simplicity, I'm just taking the get methods. So this salary will be, it's private. If it is private, then who can access? Let's say if it is a salary, if you're staying in a house, so who can access? All the members who are staying within the same house. Let's say your husband, let's say your daughter, your son, your wife, he can only access that confidential data. Can the outside neighbor can see your salary? No, it's a private data. It is not meant to be shared for the outside world. Right? So salary is a confidential data. We do not want the confidential data to be shared with the outside world. So basically, how do we hide that data? We keep that data as private, right? Or let's say, if I say, okay, Naresh, can you tell me your Gmail username password? So will you be comfortable sharing your Gmail number password? No.
No.
That's the confidential data, right? So
Yeah.
can anybody say, okay, naresh.gmail.com, he will type some password. If there is no security, he will come and he will check your email. So that's a confidential data, right? So you want that username password. Basically, your email should be accessed only by you. But then the question is, if it is accessed only by you, let's say if the salary, if it is accessed only by you, but in some cases you have to expose this salary to the outside world. Let's say your HR always is supposed to have access to your salary. You cannot say, no, I'm not going to tell my salary to any world. I mean, it's a confidential data. I'll not share it to anyone else. No, that is not the case. You have to access these information to the outside world in some cases. So how will you grant access to that? So the only way to grant access to your confidential data is by using some methods. So these attributes are private in nature. That means if it is private, no one else can access. Only you can access that attribute. But still, if you have to give access to this attribute to the outside world, the only way you can share this data is by using some public methods. So these methods, get salary and get mobile number, are public in nature. But then the question is, if it is public in nature, then does it mean that anybody can access it? The answer is no. What logic, what security mechanism you are going to put in place? So you'll say, if someone is trying to say the get salary, inside that you'll put some logic to check. If the role type is HR, then only grant access. Otherwise, get lost. Right? You would like only the HR to access your salary. Right? So Gmail also has a security mechanism. If the username is naresh.kota@gmail.com and password is ***, then only open the Gmail. Otherwise say that, no, you're not allowed. You're not the authorized person. So encapsulation, how encapsulation is implemented in Java? You keep all the attributes as private. If it is private, means no one else can access, only you can access it. But how will you share those attributes to the outside world? By using some public methods. But if you keep your methods public, does it mean that anybody can access it? The answer is no. You will write some security logic, something inside that method, that if role type is HR, then only give access to the salary. Is it okay?
Yeah.
All of you understand? So this concept is called encapsulation. Right? I mean, I can keep teaching like this. I don't want to. I think we have to put a stop. Otherwise, you all will say I'm very boring. So let me summarize what all we have covered so far today. So we started with very basics: high-level language, low-level language. Low-level language is machine language. So we saw that there is a procedural programming language. It had certain drawbacks. So C had some procedure. C was the procedural programming language. Then gradually came the concept of object-oriented programming language. Then we said what exactly object means. Any entity that we see which gives us the notion of a noun.
That is
That is called object. Object will have always attributes and some methods to act on those attributes. Right? Then we saw why Java is important. So basically we try to see some characteristics of Java. We said why Java is platform independent. I told you what is JDK, JRE, what is JVM. JVM is platform dependent, but Java is platform independent. Java is highly secured. Java has a very good exception handling mechanism. Java has multi-threading. So Java is platform independent. There are so many features of Java. Java has a provision of garbage collection. Then we saw the OOPS principle. So OOPS principle, it has basically 4 principles: abstraction, encapsulation, polymorphism, inheritance. Polymorphism has 2 flavors: method overloading and method overriding. Method overriding comes into picture whenever we have 2 classes, parent and child relationship. So whatever we inherit from the parent, if we are not happy with the default implementation, we change those implementation. So that concept is called method overriding. Method overloading, we have a same class, but we reuse the same method name with different types of arguments. So that is called method overloading. Then I said, what is method encapsulation? You want to hide the data, so you keep those data as private and you expose those data to the outside world using some public methods. So in public methods, you will write your security logic that if at all, if the user is authorized, then only grant access to that user. So this concept is called encapsulation. We all understood what is abstraction. Abstraction means we hide the details, internal implementation from the user. A simple example would be, let's say if you go and visit some restaurant, you say, okay, I want to order masala dosa. Do you actually say that, okay, no, give me the details how you prepare masala dosa? Do you actually go and try to visit the kitchen, whether they have washed their hands, whether what vegetables they are using, what masala they are using? No, all you're interested in a masala dosa. How they prepare it, that's their headache. In the kitchen, they don't grant you access. Sorry.
I have a question is like, how is it even abstraction and there's going to be hiding of the data, and even in the encapsulation we do is the hiding the details, right? I mean, hiding the
Yes.
data. So
Yes.
both is the overloading and overriding happens in abstraction. Sorry,
Overloading.
sorry, that's polymorphism. Sorry, I got confused. Okay, so abstraction, how is abstraction is different from encapsulation?
Okay, we'll have to see some more examples in terms of abstraction. So there's one more concept of abstraction, but I mean, I think that will be too much for this class. So I think maybe we can cover it in a separate class. But just understand, abstraction means abstract in nature, not complete.
Okay. Okay.
I'll give one simple example just to maybe give you a flavor so that you understand, and then we'll wrap it up then. So let us say I have a class called shape, right? And I say there's a method called calculate area. So what should be the formula for calculate area?
Length.
Should it be, but did I say that it's a rectangle? It could be a circle as well. Did I say it's a square? Did I say it's a
Depends on
rhombus?
what the area is.
Exactly. So we don't know, right? We don't know what should be the implementation. So if we are not sure what is the implementation of calculate area, we cannot define the definition of calculate area. But let us say I'm talking of two-dimensional shape. Please listen to this concept. So I know that what is the shape type? Shape type is, I'm not talking of three-dimensional shape. I'm talking of only two-dimensional. So if it's a two-dimensional shape, will it have a height? It will always have length and breadth. It will not have a height. So what is the shape type? It is two-dimensional. But if I say calculate area, do we know what should be the area of formula for calculation of area? We don't know. So if we don't know the implementation of one particular method, but if we know that yes, one particular method is shape type is definitely going to be two-dimensional. So that means your class is a mixed type. It's not completely defined. Your class, one method is say shape type, you know that it is going to be always, we are talking of, let's say, two-dimensional shape. So let's say if shape type is always two-dimensional, but calculate area is one method which you don't know what should be the formula. So you will keep that method as abstract. So your class is not fully defined in that case. So you'll call that as a partially implemented class. So that class is called abstract class. We'll explain this, we'll revisit this concept in detail later. But abstract class is, that class can have some abstract methods which are not fully defined. It can have some methods which are fully defined. Abstract class can have all the methods fully defined, or it can have all the methods as abstract. Right? So we will actually try to understand, but just understand that abstract class is something which is not concrete, which is not complete in nature. We will try to understand in detail more, but I did not want to confuse you in the very first class. Naresh, you have any question?
No.
Okay. So Naresh, are you clear with what is abstract class?
Yes. Yeah.
Or did I confuse you?
No. I'm okay. Yeah.
Okay. So we will understand what is the difference between abstraction and encapsulation. Right?
Yeah.
But just understand that abstraction means hiding the details from the user. How do you hide those details? That is called encapsulation. How do you hide those details? By you implementing encapsulation. How do you implement encapsulation? You keep your attributes as private and you expose those attributes by public methods. Okay.
Yeah.
So
okay.
so far today, I mean, I'm not going to teach you any more new concepts today because it's already 10 o'clock. Must be a little too late for you. From next time onwards, maybe we'll try to make it more productive. Maybe all of you need to check your mic, etc., so that we don't have these connectivity issues. So we try to understand what exactly class, what exactly object means. We try to understand the OOPS principle, right? So these were just few basics. Again, we will be touching few more fundamentals in subsequent classes. And once I would have covered all the basics part, then once I would have covered all the alphabets, then I will actually start going into making sentences.
Okay.
Any questions before we wrap up? Anyone? Mona? Nitya? Naresh?
No.
No questions. Okay. So if you feel that maybe if you still want to have another class, we can have tomorrow another class. But tomorrow maybe we would like to start a little bit earlier, maybe around 7 o'clock. Okay.
Okay. Yeah.
Nitya?
Okay.
Not okay?
Okay.
Okay. So I mean, because otherwise, if I keep too much of gap, then probably we'll lose the continuity.
Sure.
So I mean, what I expect from you is, before we do the next class, please watch this video again. If you're working somewhere, I would strongly recommend you download this video on a mobile phone, and maybe you can utilize the tube timing to watch these videos.
Yeah, sure.
Okay. Okay then. See you tomorrow then.
Okay.
Yeah.
Thank you.
Good night.